Alright, for this first one I'm going to share one of my favorite tips. I don't think he said it, but if I want to work on the left side, I'm just going to think when in doubt, I'm going to switch everything like this tan into sines and cosines, especially when I look down the road here and say, oh, I'm trying to get to sine and cosine land, so I'm going to go ahead and switch that. So tan is sine over cosine. I'm just ignoring the ln the whole time for now. Now, how do I make that keep going? Well, let's see. The other one has two terms, and the left side only has one. And so normally I'm thinking, how do I turn one term into two? Oh, there's a fraction bar. I could split up the fraction bar. I could, oh, well, this whole thing is going to be a little trick dealing with ln. And so I can, oh, right. ln of a quotient is a subtraction, a difference. And now that equals that. Check. That's what I wanted. Now, an alternative, I'll do this in blue. I could have done this problem. I could have said, you know, the right side looks more complicated. Maybe I should simplify it. And clearly the left side only has one. I know ln, they're both the same ln, so I could rewrite that minus as a division. And I could just put sine over cosine here. And then once I'm there, I could be, oh, well, that's just tan, and okay, now I'm done. Or you could even do both of those and stop right here, check mark. Number 2. Tan cotan equals 1. Let me show you something illegal, just to emphasize this. These are things I'm proving, so they're not actually equal signs. So hopefully you didn't do this. You can't do stuff across the equal signs. You can't just be like, oh, divide both sides by cotan, divide by cotan, now it just goes away, so now I have tan equals 1 over cotan, and that's an identity done. Actually, not technically done, and then so then that becomes tan, because tan and 1 over cotan are the same thing. And now I'm done. You're not allowed to do this. So what I did was divide both sides by something. But this is not actually like an equal sign. It's a, I'm hoping it's equals sign. I'm trying to prove it's equals. So you're not allowed to do that. Now, I could take that thought, potentially work with it, but I can't just divide both sides by cotan. My second step is not on each side of the equation. This 1 is not the same through an identity as 1 over cotan. Those are completely different. So, I'm going to back all that up. Now, this one is a little silly because if you know the idea of reciprocals, then by definition they multiply to get 1. And so you could almost just say, yeah, 1 equals 1. But probably the standard, well here, standard would be to replace one of these with 1 over the other. Or you could even do this. You could just say, you know what, this is sine over cosine. When in doubt, switch them all to sine over cosine, or sines and cosines. And then, lo and behold, whoosh, 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 and you get 1, and that happens to equal 1, check mark. You could have also just done that a slightly different way, but that, when in doubt, usually works. Okay, down here, cosecant, cosine, cotan. You know what? I'm just going to go ahead and blindly switch them. What's one thing I could do? Switch to sine and cosine. Cosecant goes with sine. Another way to rewrite that is cosine x over sine x. And that is cotan. Or what I was going to do over here was write this as cosine x over sine, switch everything on both sides, and now I'm done. So either I could take this one more step, or I could just stop here and say, look, now they both match, check. Oh, I forgot a cool rule. So cool rule here, so that you don't just be like, oh, I could just divide by sine, and that's what cotan is, I'm done. So that, again, that's illegal on these. So one way to avoid that I kind of like to do, I forgot about this, is to draw like a line to just say, I'm not allowed to do anything over there. So I have to transform them both. You know what a good strategy is? Let's switch everything to sine and cosine. So this would be cosine x over sine x times sine x, and then whoosh, whoosh, and I get cosine over 1, so I get cosine x on this side. That's what's over there, check mark. Let's move on. Golly, I love these problems. Wow, didn't we already do this? I mean, yeah, pretty much. This is just cosine over sine. In general, don't be so lazy like this, but I'm feeling lazy. Like that is just, I mean, that's terrible. You can't. Okay, so then you need an X in here, you need X in here, you need these around here. Okay. But these, oh, and you need this, and wow, wow, that was, I'm sorry. I'm just going to move on. Wow, good golly, they're so, wow. What do we, wow, oh boy. Okay, how about we do the right side as sine, so what if I just get this to be sine? But I have that thing minus 1 all over that thing plus 1. This would be a good time for lickum over lickum, which is an amazing trick that I haven't taught you yet. So I'm not sure how to do that. I'm just going to do it. So lickum over lickum is to multiply, if you multiply the top and bottom by the least common multiple of any fraction within these fractions, good things happen. That's just multiplying this whole thing by a clever form of 1, because if okay, so there's only one denominator within this, and its sine is the only denominator. So if I multiply this by sine over sine, I'm not doing anything. Really, right? I'm just timesing it by 1. So if I do that, it seems weird, but that's going to have magic, because now look, if I multiply that across, I get sine over sine, which is 1. It's here. And then if I multiply it over here, I get minus sine. And then on bottom, if I multiply this over, I get 1. And if I multiply this over, I get plus sine. And that is now where I needed to go, and I'm just done. I didn't really see that coming, but I knew it was something to do. Get rid of the denominator in denominator. A non-lickum over lickum trick. I really just need to make a video just explaining that trick. I do it all the time in calculus. I actually spend a half a lesson just covering it at the beginning. Anyway, over here, the more traditional way to do that would be to say, okay, I'm going to take 1 over sine x and minus it by sine x over sine x. So now the top, that's the top fraction becomes 1 minus sine x over sine x. Then the bottom, I do the same thing, 1 over sine x plus sine x over sine x, which then goes down here to be 1 plus sine x all over sine x. And then you can flip and multiply, which basically these would cross off. And now I got to that same point, but without such a cool trick and with an awkward name, lickum over lickum. So you should just learn that one at some point. I'll maybe make a short lesson on it, but it saved me some time on this problem. Number 7. What? We practically already did this one. This, I mean, we could just say this equals 1, because C number whatever I did where I proved that identity, once I prove an identity, I could use it. Or I could just go back to, I could just change this to 1 over tan, and then it equals 1, and then 1 plus 1 is 2 all day, check mark, moving on. Oh boy, this one is, we stepped it up a bit. Yeah. Well, we got some options. Let me show you one. This is what I would do. Left side, let's see, the right side has no denominator currently, so there's got to be a way to somehow cancel this denominator. I see a cosine squared, right? Just cross that. No, don't ever, wow, don't ever do that. That's terrible. Here's a trick to give you a little bit of breathing room, maybe some steps, is to say, when in doubt, right, do this, and then that becomes crisscross applesauce. This would be cosine x plus 1 all over cosine x if I just got common denominators. That gives me a little bit of maybe some I don't know, plan. I mean, I know what to do, but trying to see how I could explain it to y'all. So let's see. The bottom is still allowed to have a cosine. Somehow I have to magically turn the minus into a plus and get rid of the other thing. Wow, this looks interesting. Well, I don't have any other way to just do this other than doing this. So that's such a dumb sentence. So one thing, I'll pretend I don't see this wonderful difference of two squares up here. I could do this, and then my goal would be to just, how do I get rid of a cosine minus 1? Because now I have this cosine is on top and on bottom. Or sorry, the cosine's on both. Now I just got to get rid of that other cosine minus 1. Oh, cosine minus 1, cosine minus... No, you can't. Stop it. Don't do that. Okay, so this is a difference of two squares on top. So this would be cosine minus 1 and cosine plus 1. Because... oops. Go back. Okay, because of this, right? A squared minus b squared, so cosine squared minus 1 squared is cosine minus 1 cosine plus 1. Now that cosine minus 1 is going to cancel. I probably should have written in the other order, so I'll write this in the other order. Cosine minus 1. I'm just copying this down. Cosine. And now I can cross off this. Now let's pretend I didn't do that work on the other side. Now I'm at this step, cosine x plus 1 over cosine. And then a common thing to do here is the other one has just one term, kind of, or sorry, two terms. So I just need to split this into two fractions. As long as the plus is on top, I can just split it up as cosine x over cosine x plus 1 over cosine x. And now this becomes 1 plus secant in the very next step, and I can be done. Should probably actually write it. Now, since I had actually done, since I had done a little bit of work, I could have stopped here, because that's what I have here. Since you can meet in the middle like that. So that one, wow, much trickier. Also, much more fun. So, is there another one? Oh, yes. Is there? Oh, two more. How exciting. Are these going to be as delightful as that one? You know what you could do if you are in doubt? When you are in doubt, sine and cosine. So this would become 1 over cosine over 1 over sine, also known as the sine goes all the way up on top. This would be sine x over cosine x. And then I have another plus sine x over cosine x. Oh, both of those are a clever form of tan. So I could either combine like terms now and call it 2 of those, or I could switch them both to tan, which I'm going to do just because. So tan x, and that is 2 tan x, and that's what I was trying to show. You could do some crisscross applesauce, get common denominators, fun stuff like that. So I could multiply cosine over cosine, multiply sine, cosecant over cosecant gives me this as a big fraction, but note cosine times secant is 1, sine times cosecant is 1, and then I have all of this is over cosine cosecant. Cosine cosecant is the same as that. So now I have 2 over cosine over sine, which becomes 2 sine over cosine, which becomes tangent. And that, so 2 tan. Now that way was pretty ridiculous, but it worked. I love these problems. I hope you enjoyed them, at least a little bit. Oh, man. Lick 'em over lick 'em. Here we go. Maybe you could do some crazy work on the left, but to me, when in doubt, if I switch these guys, especially because they'll become cosines, which is what I have on the other side, Now's another chance for me to do my cool new lick'em over lick'em, which is just if I took this times cosine and cosine, all the denominators will cancel out. That's going to give me a cosine here, but just a plus 1 here, so plus 1. And then on bottom, it's going to give me a cosine and minus 1. And then I'm done. Man, that's such a cool trick. I suppose if you wanted to work on the left side, you could just do the same thing and change the cosines to 1 over secant, and then it'd be the same cool trick.